Hey, what's up? This is Paul Solt from Super Easy Apps, and I wanted to show you what is new with Swift 4.2. So if you want to learn, click the like button. I'm going to take you on a tour. I'm going to show you a bunch of different things that are different in Swift 4.2, and we're first going to start with Ol Begamon. He's got this great playground that we can play around with. Paul Hudson also has another one that you can look at. I'm just going to dig into this one. And there's some things I want to show you. I want to show you some gotchas and things that you might run into if you're trying to follow along and how to recover from them. There's a couple errors that I've run into on Xcode 10 beta 1. So if you're trying to use the new beta, you're going to want to watch this video. All right, so let's dive right in. First off, you're going to want to go to the link down below. I'm going to include that link down below for this GitHub repository and this article, so you can check that out. And the other thing I want to point out is Apple has a changelog, and this is what I've been looking for a while. It's like, what is different in Swift 4 and 5? And so this is where you can go. This link, again, will be in the bottom down below, but this is the changelog from the Swift repository, and you can see that we already have something in here for Swift 5, but then down below, we can see the changelog for Swift 4.2, and this has links to all the different proposals. Now, this doesn't have links to everything, so not everything is included here, and that's where it's also useful to look at this other website that Apple has, and this one's a little bit out of date because I think I just submitted an issue. It wasn't catching all of the proposals. I don't know if there's any others that are sort of hidden, but there was one more that I'm going to talk about in this video that was not covered by Ol in his playground. So if you want to learn about that one, stick around and I'm going to explain that new one. So there's 16 proposals that are listed here. We can filter by different things. So this is a really cool feature. The filter allows me to go for like Swift 5. Right now, there's no implemented ones. We can look at the accepted for Swift 5 or something like that. And so that's the cool feature. The implemented is really nice. We can see everything that's new, and you can sort of scroll through and see these things. So you're going to see some different stuff here. There's some package manager stuff I'm not going to get into, so you can dive into that a little bit later. Ol doesn't cover that in his playground, and I'll probably do that as a separate video if you're interested. So click the like button, comment down below if this is helpful or if you've got questions about any of these, and let's dive in. So I've got Xcode beta 1. I've had a couple crashes, so bear with me if it does lock up, if it does crash. Sometimes I found that the playground became unresponsive, so I'll try and show you what to do, as well as cover things, because Apple didn't really cover this, and this was in their WWDC talk. They had a talk on using playgrounds. They really didn't cover all of the things that I wanted to know and some of the error cases, so we're going to dive into that. So let's get started. We can go through the contents, and we'll start with the bool toggle. So this just allows us to change a Boolean value. So before we would do something like this, and let me just increase the font size so this is a little bit easier to read. Before, what we would do is we had to flip the bit, and so you would have to assign it the not operator of the value itself. And so this is error prone because if I had two different values, let's say I had var dark mode, so is dark mode, and this is true, potentially what you could run into is you could say is dark mode. And if we go ahead and do that, and that would be a potential issue because now you're flipping it based on another thing. So this is something that's hard to find. So that would be bad. So that's a bug. It should be is hidden. All right, so I'll get rid of that. So that is a potential bug that you could run into with this. So now what we have is a toggle, which will flip that bit. And so you can just say something like view.layer.isHidden.toggle, and it will go ahead, and if the playground runs, now this is where I sometimes run into issues. Right now, let's see what mode we're in. So this isn't automatically run. It doesn't always run. And the keyboard shortcuts do not work for this. I need to do another video on keyboard shortcuts with playgrounds because I find this really frustrating to work with sometimes. So I'm going to hit this play button down here, and we'll see that it runs. And if we want to look at these values, it's only showing me one of these, which is kind of weird. So I'll hit that play again. So if you're seeing this now, Apple showed some stuff with Xcode 10. Let's try and play with that. In order to get to that, you have to do a long press down here and switch over to manual run. They never covered that, at least that I saw in the video. So that will put you into this new execution mode. Now here you can only run top level elements. So I can run this line of code or this chunk of code, but I can't. You'll see a gray if I try to execute an inner line. So it has to be bottom of the scope. So if there's a function or if there's a structure or something, you can go ahead, compile that code and sort of step through. So we can compile all the way to the view, and then we can compile this stuff. And for some reason, it's not appearing over on the right side. So we're gonna have to investigate that. And we're only seeing one output right now. That's kind of a little annoying. So I'm going to just quit Xcode, open it up again, see if it behaves any different. This, in my mind, like Playgrounds needs a lot of work, and it's never always worked for me. I like the concept of Playgrounds, but they're too flaky, and I don't know how other people get by, but I'm going to try and show you that workaround. So quitting Xcode, reopening it, fix that. So we're a lot better right now. So you can see that this is going to toggle the value, but this is going to cause a bug. So that's the main benefit of using toggle in your code. It can prevent this type of bug that I demonstrated above. All right. So that's why you want toggle, and we can flip from true to false. It's super, super useful. All right. So let's go to the next page, and I'll just click on that link. You can click on these links to navigate on the top. So now there's a new all satisfy, and this allows you to sort of have these function predicates where you can do different things. So if we can take all the digits, we can say all smaller than 10, and we can write a little closure block here that will give us this expression. And then if we go ahead and execute it, we can show the value below. What you're going to see in here is all has written the same value again, just so it prints out the value on the right side. That's just a sort of nicety in the Playground, because by default, for whatever reason, it doesn't display the actual value on this line. It only displays how many times it's executed, which is fine. If you click the show result or the button here, you can see that. So this is going to give you the preview of this value, and this button is going to do it in line. So it's going to keep the value in line. So now if I wanted to, let's change this top one. I'm going to go ahead and let's just comment this one out and write it again. Let's change this to go up to 100. We're now going to have a different set of numbers. And so when we do all smaller than 10, it's going to be false. And we can click on this and we can see the bounds. And I don't know if we can, it's only going to show me the last value. So that's going to be what we see with a bounds. I was hoping that we could actually see, this is going to be our closed range. So there's that. That's pretty cool. So that's how we can sort of flip it. So this will makes it false. So I'll just leave that there. I'll comment it back over so that you can play around with that. All digits are even. And so here we can take the digits that we have and we can say, okay, are the digits all even? If we do the current value and we do the modulo operator, if its remainder is going to be 0, so what we're saying is the remainder of a division by 2, if that's going to be equal to 0, then we know that it's an even number. And so we can write that sort of closure expression. Now, this is a shorthand for how these need to be written. And I'm just going to show it for this one. I'm not going to show it for all of them, I don't think. So if I want to say digits, as you're typing this, dot all satisfy, what you're going to see is there's this predicate parameter, and that's going to take a function. So it's going to be a int, and it's going to return a bool. So all we have to do here is implement something. And so you can pass this a function that matches that same type, or you can write the code here. So you can write something like this. And so what this is going to say is that for each element, this is sort of a special syntactic sugar for the first element. If that's less than 10, then it's going to return something. And if we look at this, we can see that that's going to be true. All right, so that's another way to write it. This is sort of the shorthand notation, and so that's why you'll see that difference. But this is a new function that has been added, and it's super nice. All right, so the other thing is we have last where and last index and last index of. This just allows us to get the last instance of a value. So if we go back to those numbers, the last, what we're going to be asking here is the last even number from that sequence. So that is our last even number. And we can see that that's what we're writing as the variable name. So that sort of helps that up. If we want to look at the last word break, you can do this type of stuff as well. So the main thing is there was ways to do this going in one direction, but there weren't ways to do it in the other direction. And so Apple added this based on the open source community, just sort of fixing up some of these things. Another thing that we have is that you're going to see some code changes with the index of and the index where. If you've used these before, these are now changing, so you'll get fix-its in order to fix this up. All right, so that's it for some of these. These are pretty straightforward. Some of the examples you can dive into to sort of further understand them. This one, I'm not going to explain in detail, so let's jump to the next one. All right, so with this one, we can now enumerate over enum cases. This is useful. I've had numerous students of mine who are like, how do I iterate over my cases? And they can't figure it out because it hasn't been supported until now. So now that you can do that, you can just conform to the case iterable and you get this for free. So you can just say all cases and you can get the count. And if we do this, we can see all of the values for the cases. So this is really useful if I go ahead and add a new case. So let's go ahead and add, just add Arctic. And so we'll have a new case. And so if this reruns, we will now see that we have Arctic in there as the list. This is a scrollable list, and we can see that the count is now 5 over on the right side. So that's really nice. This doesn't work for everything. So there are a couple gotchas and caveats where this isn't working. And he goes into an example here. I'm not going to really cover that. And then also Paul Hudson covered an example where if you have any of the availability flags for some of your enumerations, that will potentially break the case iterable, at least in the current version. I don't know if there's an open bug on that right now. So something that you can submit a bug for if it's not working for you. All right, so let's go to the next page. Random numbers have totally changed, and it's for the better. Before, it was this archaic API. I even wrote a blog post on this because I found it so confusing, and it just felt weird that I had to use these C APIs in order to create random numbers. Now, in finally Swift 4.2, we get support for this. This is super nice. You can now just say a type and get a random number in a range. So you can use the range operator, so we can go from 1 all the way up to 1,000 inclusive, and that will give us a range. Now, if you switch this over to manually run, when we go ahead, so now this is a past run, we're going to see that faded out, but now I can execute this. Now, I ran into some problems. This link actually, and I don't know if I'm going to run into it this time, but having a period after a link apparently breaks some of this functionality. So I won't be able to go to the next example, but we'll try and work down the page. All right, so that's something I have to submit as a bug, and you can do the same if it's still a problem. So let's find out. So I can run this. That's going to do 896, and if we run it again, we'll keep getting different random numbers in different ranges. So we've got a random double, a random 8-bit integer, and so on. So if we want to rerun this again, hitting this won't rerun it, and I don't know if there's a hotkey. There is no way that I know to easily rerun this. You actually have to restart the playground. The way you do that is you have to hit the stop button. That'll take execution back to the top, and then we can rerun these and we'll get different numbers. So if you hit stop and play, that's actually going to run everything, and there's some kind of error in this. I don't fully understand what's going on the bottom. It could, yeah, I really don't know what that one is. I saw that one before when I was going through this. All right, so if we're trying to do this follow along API, you'll notice that the playhead gets gray on a line that you've already done, and you can't do it at the top of or inside a function because this needs to be done at the bottom. So I talked about this before. You have to do it at the bottom. Unfortunately, it's broken right now in the first beta. And in order to get that to work, you actually, in this one, you have to turn off the render documentation and fix this link. And for the most part, this seems to fix this problem. But if you see this in a playground, just click on this render documentation that's under the, I think this is the file tab. So if you just click on this icon, what is it called? It's called the file inspector over in the utility panel. And if you just turn off render documentation, you can also get to this from the menu up top, editor, show rendered markup. This is way faster to turn on and off. So I like this button. So if we turn that off, getting rid of this period here, now you see that gets all blue. Now we can go ahead and run this. So we can execute this chunk. And now I should be able to execute this and this line. So this is sort of letting me step through. I'll turn the render back on so that we can just sort of step through here. So we can use bool random, and so that's what's being used here. So there's this big example just to do coin tosses and figure out how many heads or tails. So if we do the inline here, we should be able to see how many heads. So this had 47 heads, 53 tails. We could rerun. If I stop and I rerun, we'll get a different coin toss, and we're going to see 46 to 54. I'll stop, rerun. We're going to see more output. We got 50-50, which is what we'd expect. All right, so moving on, we can also get random elements. Now, this will come back as a optional element. So if we're working with characters, it's going to be an optional character. If we're working with strings in an array, it's going to be an optional sort of string and that type of stuff. So you'll have to do the force in order to actually use that value. And then we also have the shuffled API as well as shuffle. So shuffled will return a copy of the sequence, and shuffle will actually rearrange the sequence. So that's the difference between those two. And then you can do custom random number generators. Now, this is what's blowing up for some reason. I don't fully understand it. There's some kind of issue, but it's not an issue. This is a sort of a fake random number, sort of implementing the API. So you can go ahead and add your own APIs and custom logic that will actually implement different random number generators. Now, this is something that most people will not need to do, but if you're doing anything with cryptography, you're going to want control over the algorithms that you're using in order to keep it secure. And so you might go about using a custom generator here. All right, for most people, you don't even need to worry about that, so don't worry. And then what you can also do is you can extend your own types so that you can get a random function, and you could go ahead and pull out different things like that. So this we can see will give us a random suit, and you can get access to clubs. And so we'll see that it is the clubs. And then when we actually get the raw value, we see that we're using these special Unicode values, and we can see those appear here. So that's a little bit of working with random, way better than using arc4 random underscore uniform and then dealing with the different number formats. So I'm super excited about that. Let's move on to the next page. All right, so we've got the hashable redesign. This has been something that has also really bothered me all the way back to Objective-C. Is it's really hard to know how to write a good hashable function for a custom type. And if you do it wrong, then you have security issues, you have performance issues, and all kinds of things that you'll run into if you're working with sets or if you're working with dictionaries. So this is something that fixes some of that, and it makes it way, 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 way easier to work with hash types. So here we have an example, and we've got some variables in this point structure that can be set. And then we also have some functions, and we have, we're adding equatability. So we only care about sort of matching these two in terms of equatability. We don't care about the distance from the origin. That's not something that we need to test against for a particular point. That's sort of a convenience helper function type of thing. So distance from origin is a cached value that's private on the setter. So it's only set from the different functions. So when you go ahead to create a point, it will actually cache that value automatically in the sample code and do that calculation for you. And so the whole point here is we can override the equatable, but jumping back into hashable, what we're going to want to do is only hash the x and the y. We don't want to hash that distance from origin, since that's based on the x and the y coordinates. So when you have information that is sort of computed based on other information, that's not something that you would include in your hash algorithm. And the other thing that we would run into is previously a lot of developers would tell you to like just use the bitwise OR when you're doing your hash function, and that results in the same value. So if we go ahead and we can run this, what we'll see is that the hash values should be unique values. And if we go ahead and run this and we run this assertion, it should not throw. Now, if I wanted to try, okay, well, what happens if I comment this out and I write a hash function that's not going to be unique? So in the example above, if we try to combine the x and then we do the XOR function, what we'll see is that if we run this again, we are going to get the same exact value. You'll see this for both of those values. And so we'll actually throw that assertion and you'll see this error gets thrown out. So you'll see assertion failed, that it just crashed. And so that means that they're equal. And if we look at the values themselves, we can say that they are the same. Now, another thing that Apple has done, and I'm not sure if this is going to work. Let's find out. If I rerun this, you're going to see that these are different every time. And this is a security thing. So if I stop this and run it one more time, you'll see a new value every time. If you do need to prevent that from being random, there is a compiler flag. You can't, I think, do it in a playground unless it's part of like a workspace potentially. So that's something that is to help protect against security. So we will always want to combine these things separately. And so that's what this combine function is. So this will result in same value, which would give us basically clashes with hash, and that's bad. We don't want to have conflicts with our hash function because then the same value gets put in the same spot, and then the lookups are going to take linear time rather than a much better sort of performance, which we'd expect from a dictionary type structure. All right, so that's a little bit of working with the hasher. This makes it way easier. If you have different things, you can just combine them and you can ignore other values that don't need to be included here, which is super useful when you're overriding your own hashable implementation. Now, you can get hashable for free, but probably you're going to have some properties in there that you want to exclude. All right, let's go to the next page. Conditional conformance enhancements. This sort of just improves working with collections of things. And I don't know if we have a really good example here. I'm going to hide this sidebar. You can dig into this a little bit more, but we would see that in Swift 4.1, some of this stuff didn't work and it would actually fail. And so Swift 4.2 just makes this a little bit more natural. This is, I would say, a more advanced topic. So if you're interested in the details, I would check out this link. You can just click this. That will open up the Git proposal, not the Git proposal, the Swift evolution proposal, and you can sort of see the motivation, some sample code. These are a little bit dense to read, so it's nice when you can find someone who's written something up. So I would take a look at this and sort of really understand how this is going to work. I think I'm just going to jump on over it. I don't know if this is the best way of understanding this, but the What's New Swift session, if you jump into this will, again, walk you through with Apple's video so that you can sort of see how that's going to work. So that's another good resource to look at. All right. Let's go to the next page. Dynamic member lookup. Now, this one's interesting, and I like this example better than the example that Paul Hudson gave because it makes it more applicable. And this is actually coming from Doug Greger over at Apple. and he implemented this little chunk of code and put it in a gist, and you can go ahead and play around with this. But this basically allows you to set some environmental variables, get those environmental variables using this new dynamic lookup where you can provide a string value and it sort of gets used in this special subscript dynamic member thing. And I think this is because of some of the stuff in TensorFlow that Chris Latner is working on, and sort of its link into Python. So that's something to take a look at. And let's jump in and hit the play button. And what we're going to see, if I can make this a little bigger, is this is going to show me my environmental variables. Now, typically, if you want to get access to something like this, you would open up your terminal app and you could write something like echo. And then if we want to look at user, you would type user, and that would tell you who you are as the user. And you'll see that we can get access to those same things right here within a Swift application. So this is a super useful way of looking up those values and using sort of this feature where you can just type these values. Now, if you type this wrong, it's not going to work and you'll probably get something that you don't expect. So if I type user, it actually is case sensitive. And let's see what happens if we run this. So if I do play, we'll see that this will return nil. So there is no value set. And that's the one thing that Ol didn't include in here, is he didn't show you what happens when you unset them. You can unset environmental variables. If you've ever worked with environmental variables, if you ever want to unset them, you can unset. And this is something that Doug mentioned in his little write-up on his link. If you just jump here, and if you want to jump to that, I don't know if this works. It doesn't look like it's picking that up, but that is the gist that you can click on. Do I have that disabled? No. If we do this, there we go. And that gives you a link, and you should be able to, if you hold the command key, you can click on that and see the actual original. So this was super cool. I saw it on Twitter, and this just allows you to do some things that haven't been possible before. Ol talks about this, talking about how it might make more sense to use something like environment user. I don't know if I agree with that. I think this just makes it super easy, especially when we're trying to connect to some scripting type of thing where we're working with anything like that. I think this can be really useful. I don't know how people are going to actually use this beyond this example, but this was kind of a cool little example. All right, so let's go to the next page and see what's over here. All right, this is cool. Harlan Haskin worked on this, and he actually went to RIT, where I went as well, and I've met him a few times, even at Apple. I had lunch with him there. And so this was cool to see that he got this in. He was working at Apple, and then he's working at Google, and he's still working on a lot of Swift-related things. So that was super cool. And you can click this link to read all about it. But the gist of this is that we can get warnings based in the code that we're writing. So if you didn't get to finish something and you want a warning so that you can go back to it and have reference to it, this is super useful. You just do the pound symbol and you can add your own warnings. The same is true if we want an error. So we can go ahead and put an error. And it looks like, since we're, I think, in a Cocoa playground, this is not executing. So AppKit can be imported. So what I'm just going to do is I'm just going to write a new one. Error, this code needs more work. So if we go ahead and do that, what you're going to see is this brings an error. Now, if you're in Xcode, you can go to the issues and you can see that these two both show up in this sidebar. All right, I'm going to hide that sidebar again just so that we can focus on this. But that's super useful. And let's jump to the next page. And the other thing to keep in mind is that this sort of keeps the same style. And you can read more about that in the SE 196, but it stays sort of in line with some of the other enhancements we've seen with the Swift language, like the selector syntax. All right, so another one, if you've ever worked with any of the memory management stuff, if you're working with raw data, So if you're doing pixel data or if you're doing any kind of image data from a video and stuff like that, you'll have access to the different memory layout. Now, I've worked a little bit with this with working in AV Foundation. I was trying to get color values out of a video frame and just sort of investigating the values. So this is just another tool in your chest of tools for working with memory, and this gives you offset points. Now, this isn't really a great example in my mind of showing you exactly what's here. So I'm going to just add a couple more things. I think that it's helpful to see sort of the layout, and then it's also helpful. You can use memory layouts to also tell you how big something is. So we can see how big this is. And let's go ahead and just for fun, show you how big a float is. In case you don't know, we can go ahead and do that. So if we go ahead and run, and I think I'm on manual run now. I think it's switching between the different pages. I'm not entirely certain. So we can execute this. Again, we can't execute the inner stuff. We can execute this and we'll see 12 over on the right and then 4. So a float is 4. So, okay, well, what's a double? We go ahead and add that. We can see a double is 8. So that's the number of bytes that we're talking about. And so then just running this, we can see that this is going to be 0, 4, and 8. So that's going to be the offset position of these different values. And this is just useful when you're working with pixel data and that type of thing. It just didn't exist before, and so it was kind of error prone. You had to keep in mind what the sizes were. And so this just gives you an explicit way that's always safe, that's checked by the compiler so that you can get access to that type of stuff. All right, so that's that. Now, if I wanted to, I could go ahead and let's say I wanted to add a rectangle or something. So I could do rect and I could do CG rect. I think I would need to import Cocoa or something. And so now if it still likes me, let's see. We're going to see is the size is going to be a lot bigger. And so if I wanted to know what our rect is, we'll see that the rect now starts at position 16. And the size of, if we want to look at that, we look at memory layout for a CG rect dot size, we are going to get a value. If I do shift enter, it should run that line. So we'll see that's 32. And I can click down here to run this. So a CG rect is 32. And why is it 32? Well, if we can, there's no easy way to get to that. There we go. It's 32 because we're going to have an origin and a size. And each of these is composed of something else. We're going to see that these are CG floats, and depending on your type, this is probably going to be a double on a 64-bit architecture, so that's sort of why. So we're going to see that 8 times 4 is going to give us 32. So that's a little bit about working with the pointers. I need to probably do a video on all the shortcuts in Xcode because I've changed a couple, and I don't know them off the top of my head very well. I just keep clicking until it works. All right, so that's a little bit of doing the memory layout. I don't know what happened to our heading. Did I accidentally delete that? For some reason, the markdown failed to render after we... No. I'm missing all of that stuff. Is it being hidden? Or I accidentally deleted it? Not really sure. All right, so let's go to the next page. So that's a little memory layout. The next one is Inlinable. I really don't think this is probably something that you're going to use. This allows something to optimize your code. And there's a little example here. And this will just go through and just see if something's all equal. We can go ahead and run it. And we're going to see false for this collection. So this is just a little function that he provided that is going to iterate and it's using this Inlinable. Now you have to be careful with this, and he's got some warnings. So I would take that into account, and I would definitely check out the proposal if you plan to do this. This is an optimization thing, and I wouldn't be doing this in your code. This makes it a little bit less readable. There's probably reasons for where this makes sense, and I would say for 99.9% of people, don't use this because it has a lot of implications, and if you don't understand what those are, then it can be pretty dangerous in the binaries that you release once we have ABI compatibility. So that's going to be something to keep in mind. All right, so another one is calling with unsafe pointer. And so this is something that if you've ever done anything with AB Foundation and pixel buffers, you're going to run into this type of stuff. You couldn't call this with immutable values. You actually had to provide a mutable pointer in order to do it. And this adds some stuff. If I click on this, you can read more about it. But this allows you to use a non-mutable pointer here. And so that's cool. We can see an example here. This is going to step through. So if we step through here, we're going to see that we've got these 2 bytes. So we've got A, B, and C, D as our bytes, and this is in hexadecimal. And then what we can do is we can print out the different values, and so we can use a string overload in order to get those values. So what's happening here is we're getting the return value of these 2 things. So basically what we've done here is we're getting the unsafe byte. So we're trying to get to the byte data of this int. This is an unsigned int 16. And we want to get the unsafe bytes of this. And in order to do that, we're going to get access to the pointer. So this is going to give us access to a raw pointer like you would have in C++. And now you can index these things. Now, this is potentially unsafe because if I do this, we're going to be indexing out of bounds. And if I were to run this again, we're going to see that this crashes. So this is why C++ and C code can be really unsafe. And your Swift code that is working with unsafe pointers and stuff like that is potentially dangerous. So you have to be careful. This only has 2 bytes of data, which we can see right here. Because of the type, we know it's 16. This is providing 16 bits, and this is the other 16 bits. So that's why you can't go past that, because you're going out of bounds, and it's going to crash. Well, what we're doing is this is an implicit return. So this is a closure that's being run, and then we're implicitly returning a tuple containing 2 values. That's going to be the pointer's first value and the second value. These get passed back by a copy because they are a primitive data type. They're not a reference. So it's not going to give us raw access to that pointer. That would be unsafe. That would be dangerous in your app because it can get optimized out. So we'll pass back some of the data as a tuple. And then what we can do is we can convert that into a string format that we can actually read. Now, if I change this radix to 10, what you'll see when we run this is this will be 205, and that's what you see up top here. So that's base 10, but if we want to do this in hexadecimal, we're going to change that to 16, and if we rerun this, you'll see that this is CD. Now, there is another overload for this, and actually the full overload I found was interesting just because I was just sort of digging into this API. Autocomplete doesn't always bring this up, but there is a byte, and I don't know if I can find it quickly. This is the one that we're doing. We're doing this binary integer. So if I double click this, so this is the function that all is using here. So we can pass in the first byte, and you can give it a radix, which is the base. So base 16, which is hexadecimal, is typically what we'll see in a lot of things. And you can also do the uppercase, which wasn't there. So I thought that was kind of cool. We can go ahead and run this line, and you can see that that'll give us CD. So if you want uppercase, that's how you do it. That's how you work with the unsafe pointers. All right, so that was it for this tutorial, but I kind of wanted to add a new page. And so I'm going to go ahead and I don't know if I can copy this. I want to copy that last page. If we're on this last page, if I go to File, New, Playground page, that'll add one more. And I'm just going to paste that hyperlink down here. And for this one, let's call this remove all. All right, so hopefully this works. I'm going to copy over some code that I have over here because this was not included, and this is from SE 197. This one was not visible on that one page, so in order to find it, I had to actually dig in. Paul Hudson covered this, so I thought I'd cover it here. And there's a new remove all function, which is super useful. That is supposed to be really performant. Paul has a nice write-up on it. I'll try and include that link down below. You can see all of that. He mentions it in his playground that you can play around with. All right, so the gist is you can have a collection and you can then iterate over it and filter out stuff. So previously you would use like the filter function, but that's really slow. I don't even know if this compiles right now. I don't think I've written this line of code right, but it's something like that you would write. And so what we can do now is we can remove all. And I've got a few different examples I sort of wanted to show off here. So let's take a look at them. So if I've got 1 through 6, I can say nums.filter, and then if it's not odd, and let's see if this works. And I think this is, no, I don't want to show you this. Sorry, I don't know why I commented that one out. That's not right. I need to fix this. So here is where I can pass a function, or I can also pass a, and this is, did I write it down? I didn't write it down. There's another way to write this. You can say something like let is odd equal, and you can then do something like this, and this will do an implicit type. So if we go ahead and execute this, what we'll see is, and quick help's not working for some reason, but this is going to give us that same signature that we need. So this is the same as sort of passing a function. So we can pass a function, or we can pass basically a closure to this. So we can pass is odd, and I don't think it likes that I'm renaming this. Let's actually call this is odd 2 so that it doesn't clash. So now what we can do is we can run this line of code, and we now removed all of the odd. And if I wanted to, why don't we actually turn is odd 2 into is even? So let's just make this. So in order for this to be even, what we're saying here is the value divided by 2, the remainder. If that's equal to 0, then we know that it's an even number. If it's equal to 1, we know it's an odd number. So if there's 1 remainder, we know it's odd. So this is using the modulus operator. And what we're going to do here is we're going to remove all where it's odd. If I wanted to, instead of that, remove all, and let's copy this line again, is even, and we'll uncomment that with the command /. We go ahead and run up to this. We're going to see we get 135. All right, so that's another way to do this same type of code. So whether you have a function or if you have a closure that you've assigned to a variable, you can pass those in and leverage them. Now, if you didn't want to do that and you want to write the closure right there, you could also do that as well. So I'm just going to uncomment this one so that we can sort of step through that. And again, it's just a different way of writing it. So that's one way. And if we run this, you'll see that it will execute. And now I think I have to put nums below it to actually see the value. Let's execute that line. We see 246. All right, so that's removing all like that. Again, we can do the same type of thing if this is I just want to show this because I found this useful to sort of see a trailing closure. Since the where takes a closure, we can actually do a trailing closure. So if you wanted to do something like this, you could do something like this. And this is actually if it's even. So I'm just going to get rid of that because that doesn't match what the code is now doing. And that will remove it. So we could go ahead and run this. Now, in order to run this, we click the run button. And I think I have to click it down here for this trailing closure. And there we go. Now we see the value. I don't know why. For some reason, oh, maybe it's because it was all on one line. If we go back up to that, we run this, it'll tell us 7 times. But if I had actually put this on the next line, let's see if that behaves any different. So now it's going to show us those values. So for some reason, putting it all on one line prevents it from showing the result, which is why I put it on 2 lines. So that's super cool. I'll leave this one on, and I'm probably just going to remove this one so I don't confuse myself again. All right, so the next thing is in SE 202, we got random numbers and shuffling. And actually, I already covered the shuffling, so I just put this in here because I didn't think I saw it, but I definitely did see it in what Ol had in this. So that's actually not really relevant for what we're talking about. All right, so that's pretty much it. If you want to look at the rest of the changes, or if this was helpful, click the like button. Share this if you enjoyed it. And if you want to check out any of those proposals, there should be 17. I submitted a pull request to hopefully get that fixed. And I think that was all of them, but there might be another one lurking somewhere. If you want to check out the package manager, there's a couple ones in here. I think we pretty much covered all of the other ones. These are a little bit dense to read, and as a beginner, not all of them make sense for you. So it's something to be aware of. Probably the last where and last index of, hashable, all satisfy. Those are probably going to be the most common ones, and conditional conformances, which you're probably never going to understand exactly, but it's just going to work before it just didn't work. So that just allows you to work with your arrays where the things are equatable, and then the array becomes equatable. And before that wasn't the case. So that is now the case. And the other thing I didn't talk about is that they abolished the implicitly unwrapped optional type. It is no longer a special type. This is a little bit confusing, but it is now just an optional that just sort of gets some syntactic sugar from what I understand, so that it automatically sort of unwraps itself, but it is still just an optional. And so some of your code, if you had an array of implicitly unwrapped optionals, that's no longer possible. It has to be an array of optional values. And so that's the one other difference. All right, so that's it for Swift 4.2. Again, if you like this, click the like button. I've got links down below that covers this, and I'll include my version of this repository if you want to sort of step through the code that I walk through in this video. Otherwise, you can check out some of the other links that I'll provide references to. The What's New in Swift 4.2 from Paul Hudson over at Hacking with Swift is super nice. Again, he talks about some of the other things, so you can go here, see some code samples, some different perspectives. It might make more or less sense to you depending on the different topic. Some of these, again, are more advanced topics that you don't really need to worry about when you're making iPhone apps. It's just going to shift the language a little bit, and by and large, not everything is applicable to you. So don't worry too much about that, but take a look at it. All right, so I will catch you in the next video. Thanks for watching, and I will see you later.